Hello everybody and welcome back to our continuing progress to the 2011 Senior Mathematics Contest. We've gone all the way through Part A and now we're on to Part B. So how about we take a look at what Part B on the contest has to offer. So you might remember from mentioning a couple other times that Part B is written solutions, and they make that apparent here in this little preamble at the start. We need a complete justification, complete explanation. We need to write things out. We need to properly communicate our ideas in a clear and concise manner in order to get full marks. Okay, each question has, I believe, 10 marks at stake. So it's very important that we write out our solutions correctly and properly. Okay. But basically, a math solution or a math proof just boils down to writing out exactly what you're doing and why you're doing it. So hopefully you can get a little practice at it, and it shouldn't be that difficult a skill to learn. It sounds scary. Write out your proofs because it's not something that's usually taught in school. But it really just means explain what you're doing and why you're doing it. Explain the patterns. How do you see the patterns, and why do you know that they will continue? But that's enough yickety-yak. Question number 1. The parabola with equation y equals 25 minus x squared intersects, I assume this is a parabola, intersects the x-axis at points A and B as shown. Okay. Determine the length of AB. Okay. Well, to determine the length of AB, we know that they're both going to have, they're going to lie on the x-axis, so their y-coordinates are both going to be 0, but we need to figure out what their x-coordinates are, and then we can tell the distance in a straight line just by figuring out the difference in their x-coordinates. Okay. So how about we draw a little bit of the picture. A, B. So A and B lie on the x-axis. So their y-coordinates are 0. Now if we want to find their x-coordinates, we'll use the equation of the parabola. They lie on the parabola. So that means that their x and y coordinates must satisfy the relationship that y is 25 minus x squared. But we know that y is going to be 0. So 0 is the same as 25 minus x squared. We can rearrange that to get x squared is equal to 25. So x is going to be negative 5 or 5. So A, because it's the one on the left-hand side, A is going to have coordinates negative 5, 0, and B will have coordinates 5, 0. What do I want to say here? So the length of B, or AB, is exactly the difference in their x-coordinates. This is true of any pair of points lying on the x-axis. If they had different y-coordinates and different x-coordinates, we would have to use the distance formula between 2 points. But because they both lie on the x-axis, they both lie on the same line. Their y values are constant. It's just going to work out to be the difference in their x-coordinates. So AB, and we're going to use the absolute value bars. It's going to be minus 5, so that's the x-coordinate of A, minus the x-coordinate of B, which is 5. So that's the absolute value of negative 10, which is 10. So the length of AB is 10. All right, and that's all we were asked for in A part. Determine the length AB. Fantastic. So we know that this distance here is 10. Rectangle ABCD is formed as shown with CD below the x-axis and BD is equal to 26. Determine the length of BC. So we want to determine the height of the rectangle, and all we know is, well, we know what AB is, we know the width, and we know a diagonal. Okay, so I'm sensing that a right angle triangle is going to appear here. Which way was it around? Okay, so A, B, C, D. D over here, C over here. And we have this distance is 10. We know this distance is 20, and let's call this distance x. So let BC and AD, so the two lengths, be equal to x. Now, since ABCD is a rectangle, then the triangle, let's say BCD, is a right angle. So by the Pythagoras Theorem, B up here, we have C, we have D. This is x, we are told this is 26, and we know this is going to be 10. BD squared is equal to BC squared plus CD squared. 26 squared is x squared plus 10 squared. Okay, well, what's 26 squared? It's going to be 676. X squared plus 100. So x squared is going to be 676 minus 100, which is 576. And x will be the square root of that. And that's going to be 24. So BC is 24, and that's all we were asked for. Okay, and we clearly explained what we were doing at each stage. We put in a variable for BC, we explained that it's a rectangle, and that gives us BCD is a right angle triangle. Pythagoras' theorem gives us the rest. We got BC is 24. Alright, C part. If CD is extended in both directions, it meets the parabola at points E and F. Determine the length of E and F. Okay. So let's draw ourselves a little picture of what that is. Here's A, here's B. C, D. We're extending C and D outwards to give E and F. Okay, and we're going to distinguish these points here with, let's go with yellow. So we have A, B, we have C, we have E, we have D, and we have F. Okay. So I notice that since ABCD is a rectangle, and AB is on the x-axis, then CD is parallel to the x-axis. Okay, nice little notation for parallel. So C, D, E, and F will all have the same y-coordinate. Now we know that BC is 24. And our picture tells us that CD lies below the x-axis. This y-coordinate will be negative 24. Okay. So if we think back to part A, when we figured out the x-coordinates of A and B, well, we figured out their y-coordinate was 0 because they lie on the x-axis, and from there we used the equation of the parabola because we knew that A and B were on the parabola. We used the y-coordinate to solve for the possible x-coordinates. E and F, we're going to have the exact same scenario. So we're going to use y equals negative 24 and the equation of the parabola. So what was that again? Well, that was y equals 25 minus x squared. Okay. So that's negative 24 is 25 minus x squared. So we can rearrange these. We can bring the x squared over to this side. And we can add 24 to the right-hand side. So they're going to be 49. Fantastic. So x is going to be plus or minus the square root of 49, so that's plus or minus 7. So E, we said E is going to be the positive one, so it's going to lie at 7 and negative 24. F is going to lie at negative 7, negative 24. Just according to our picture on the previous page. We had E was positive x values, negative y values, and F was negative y values, negative x values. All right, now I believe the question asked us to find the length of EF. It absolutely did. Okay. Now I could make an argument that they both have the same y coordinates. So once again, it's going to be the difference of their x coordinates. And that is perfectly fine. That is an excellent way. No one's going to fault you for that. You still get marks. But I already did that in A part, so how about we just use the distance formula? Okay, so we can take that for a little bit of a spin in case some of you are curious as to how to apply that. So if we have x1, y1, and y2, x2, y2, then we have a nice little distance formula. x1 minus x2 squared plus y1 minus y2 squared, and then we square root that. So the distance from E to F, well, that's going to be the square root of the difference of their x coordinates. So 7 minus negative 7 squared plus negative 24 minus negative 24 squared. And we can see this is going to end up being 0. So square root of 14 squared plus 0 squared. So square root of 14 squared, 196, and that's going to be 14. So I have a little final statement here. The distance EF has a length of 14. Okay, and we've highlighted it, so it makes it very easy for the markers who are marking this to realize, yep, our answer is 14. And we showed all our work. We even used the distance formula rather than they lie on the same x coordinate, or sorry, same y coordinate argument. Both are perfectly fine, but I already used one, so I thought I'd use the other just for a little bit of variety. All right. So that concludes question number 1. In B part, we have full written solutions, just like we have with all the other parts, but this time it matters. This time our solution needs to be nice and neat and clear because we want full marks, and they do mark the solutions on B, whereas before we just needed final answers. All right, so question 1 is all done. It was a nice quick question involving an equation of a parabola. I rather like it. And we'll move on to question number 2, but we'll have to do that in the next video. So thank you so much for joining me. I'll see you for question B2 in the next video.